Earth.Otherwise here to continue our journey into game programming in C++, start to finish by Eric Yuzwa. A matrix is a two-dimensional array of numbers, usually one number by four numbers or four numbers by four numbers, depending on what you're using it for. OpenGL has three built-in matrices that you will probably be using, especially if you are doing 3D. These are the model view, projection, and texture matrix stacks. The model view matrix is used for placing and rotating objects within the game world so that everything isn't clustered at the origin. You'll remember that I mentioned that vectors are used for this. Matrices are the main way of manipulating groups of vectors. The projection matrix is used to define the volume and edges of what your camera can see. The texture matrix is used for moving where your texture is going to be placed on the models, which is really useful when you don't want your character's eyes to be on the back of their head. The book goes over some of its own matrix definitions. However, OpenGL has a bunch of definitions that we'll probably be using, so we won't worry about creating code to deal with this just yet. Matrices can be added, subtracted, and multiplied to perform multiple changes at once, like if you're rotating and moving forward at the same time. There are three transformations in graphics programming that use these matrices. These are translations, or movement, scaling, or growing and shrinking, and rotation, or rotation, as the layman might say. Scaling occurs when you apply a scalar value to each element of a matrix. By applying a scaled matrix to an object, it can grow or shrink. The images depict how matrices interact with each other and each of the coordinates on the vectors that you're applying the matrix to. This will be explained in further detail later or in other videos that I'll link in later in the series. For now, you just need to know that we use these matrices to do these things. Translation occurs when you add a vector, that is a direction and magnitude, not a point, of a spatial change, a vector that represents a spatial change, to the original points or the original vectors of your model. These are the simplest changes that we can use matrices for. Finally, there is rotation, which rotates all points around an axis. How the points rotate depends on if you're applying the rotation to the object in the world or the object itself. For example, you can rotate an entire model around the origin, or you can rotate all the vertexes or vectors of a model around its own internal axes. It's important that we use 4x4 matrices in our graphics. If matrices don't match dimensions, then you can't mix them together. I believe that if you want to mix two matrices of different sizes, then the first dimension of the first matrix will have to be the same size as the second dimension of the second matrix to allow for multiplication. This is due to some complex math reason that I don't entirely understand, but I'm certain that if we want to figure that out, we can just Google it. Obviously, keeping track of, the matrix numbers is more difficult than not at all, so we're generally going to be sticking to 4x4 matrices, and we shouldn't have too many problems. However, something you must remember is that when you mix multiple types of matrix transformations, that they occur in order from left to right. This means that if you rotate your model 180 degrees around the x-axis and then 180 degrees around the y-axis, it will look different than if you had performed those operations in the reverse order. So, here's the thing about this book. We've just talked about matrices and given some examples. However, you'll notice that I haven't said how to actually write the code for this so far. Indeed, there will not be a coding section to this part of the book. That's because the book intends for you to use the Peon engine, the one that comes with the book, the one that doesn't work. It has all the matrix math worked out and coded into it, much like another game engine somewhere else. But since the Peon engine doesn't work, we're going to have to rip the code apart and cannibalize it for our own engine. And as I mentioned, we're probably also going to use a lot of built-in OpenGL functions, as it has become more robust since 2007. I'll probably make a chapter in this series that isn't in the book about cannibalizing other code that you sort of understand, but that's for another section. Next, camera and view orientation.